strange eyeball ice world seen by Webb. Did ancient astronomers see a kilonova in the sky? Extreme moss that could handle Mars, and Ariane 6 flies successfully to space. Mostly. All this and more in this week's Space Bites. A fairly well-known exoplanet is LHS 1140b, which is located about 48 light years away. And this has been a very interesting world that astronomers have been studying for several years now. And so astronomers had been observing it, and they had narrowed it down that this world was either a mini Neptune or a super Earth. And of course, when you've got some kind of question that you can't answer yet, you bring in James Webb. And so it was able to help search the atmosphere of LHS 1140b, and it wasn't able to detect a large hydrogen gas envelope. And this is the kind of thing that you would see for a mini Neptune, an ice world like Neptune, Uranus, but smaller. And so without that hydrogen envelope, then the evidence seems to be leaning towards that this is a super Earth. But when they measured the size of the planet and calculated the density, it's about 20% less than a planet like Earth, and what you would expect if it was a rocky planet. And so this has led astronomers to think that it's a super Earth-sized world, something with 1.7 times the size of the Earth, but about 5.6 times our mass. And it appears to have a large amount of water mixed in with the rock. So one possibility is that this is another Haitian world, one of these large ocean worlds that are kept liquid water because they're surrounded by an atmosphere of hydrogen. But as we said, not enough to make it appear to be a mini Neptune. The other possibility is that the water ice is actually mixed in with the rock, and it's more like a comet at sort of the largest, vastest scale. But the third possibility, and the one that's most intriguing to me, is that it is more like Europa, that you've got this rocky center, a liquid exterior, and then you've got an ice shell that's surrounding the planet. But it's close enough to a star that it wouldn't be a complete covering of the planet. Instead, because the planet would be tidally locked to its star, you'd have this region that's open water and maybe ice flows, and then it transitions into ice as you get farther and farther away from this hotspot. And the artist's illustrations make it look like an eyeball, but is this the first example of a Europa-like water world that's out there in the universe? I want to direct you to Anton Petrov. He just did a video a couple of days ago about this and went into a lot more detail. So if you want more information, check out his video. Another habitable zone to think about. Now, you're probably familiar with the habitable zone. This is a region around a star where the temperature is just right, and so liquid water could be present on a planet that's orbiting around that star. Now, it doesn't mean that it is present, just that it could be present. And this is known as the circumstellar habitable zone, CHZ. But astronomers know of another kind of habitable zone known as the ultraviolet habitable zone. And so when you think about different kinds of stars, they are pumping out various wavelengths of radiation. And one of these that's most influential on a planet is ultraviolet. If you get too much ultraviolet radiation, then it actually starts to break down molecules in the atmosphere of the planet. If we got more ultraviolet radiation on Earth, it would start to wear down our ozone layer. More radiation would reach the Earth. It would be very bad for life as we know it here on the planet. But maybe too little ultraviolet is a problem too, that this ultraviolet provides a source of radiation, that provides a source of genetic variation, and can help drive evolution over the longest processes. So you want the right temperature for liquid water to form, and you want the right levels of ultraviolet. And the problem is that stars will have their ultraviolet levels change over time as the star ages. And so you're going to get this ultraviolet zone that's going to range out away from the star. And same thing with the habitable zone. And for us to have viable life on, say, planet Earth, you need both to be in the habitable zone and the ultraviolet habitable zone at the same time. Now, we're like that, but astronomers have to figure out how to prioritize all of the planetary systems that they're finding. And they need a way to filter down that list to look at the ones that are most interesting. And so in a new paper, astronomers are suggesting, let's focus on finding planets that are both in the habitable zone as well as the ultraviolet zone as the best chance as a place to search for life. And one of the best places to look is actually Proxima Centauri b. This is this planet that's orbiting within the habitable zone of the closest star to the sun. So another way to look for life in the universe. Did ancient people see a kilonova? We have accurate observations from ancient astronomers of various supernovae that occurred in the sky. And I think the most famous example of this is in 1054. Astronomers saw this bright star appear in the sky, lasted for several weeks, and then it faded away. And at its brightest point, it could be visible during the daytime. And we now know this is the Crab Nebula. And so this giant cloud of expanding gas and dust and debris is left over from when that supernova went off in the sky. But this is just one example. You've got Tycho's supernova. There's, of course, we saw supernova 1987A, and there was one that was recorded in 1181 by astronomers. And it was assumed this was another kind of core collapse supernova. But recently, astronomers found a white dwarf embedded at the heart of the debris cloud. And that's very strange, that you would see a white dwarf as the remnant of a supernova, not a neutron star, not a black hole, but a white dwarf. And now astronomers think this isn't a standard core collapse supernova. This is a very rare type of supernova, a type 1ax. And what you get is two white dwarfs that are in orbit around one another. They spiral inward, and then they collide and detonate, and they explode as a supernova, but they leave behind a white dwarf as the remnant. And so this is actually a type of kilonova. Now, you're probably familiar with the one that happened several years ago, where you had a collision between two neutron stars. It's been proposed you could have a neutron star black hole collision, but two white dwarfs can also create a kilonova. So the hint that this is what happened comes from this white dwarf remnant with these powerful winds that are starting to blow away from the white dwarf. And they're encountering two separate shock zones of debris as they're flowing out into space, which means that both the two white dwarfs that merged together to form the single white dwarf at a time were shedding off these outer layers of material, and the shock wave from the supernova had to pass through this additional debris. And now material from this explosion is starting to fall back down onto the white dwarf, heated up, it's blazing in X-rays, and this is how astronomers were able to find it. And so one of the brightest, best recorded supernova explosions in history might have been a kilonova. Moss that could survive on Mars. Mars is an inhospitable place. I mean, you've got this intense radiation, a very thin atmosphere, low gravity, lack of water on the surface, freezing cold temperatures. I mean, the list goes on and on. Perchlorates in the soil. Like, it's a very nasty place. And yet, astrobiologists are finding there are certain kinds of life forms that could survive those conditions on Mars. Now, not thrive. Not if you send cyanobacteria to Mars, it's not going to begin creating these giant colonies of cyanobacteria on the surface of Mars, but it's not going to be killed. It will go into hibernation, and it's just waiting for a chance for liquid water, and it could take off again. And astrobiologists are starting to discover more and more life forms like cyanobacteria. And now they found a plant that can do this. The plant is called Centrichia cananervis. And it's typically found in really extreme environments here on Earth, in Antarctica, in the Mojave Desert. And it has a lot of the same kinds of abilities that some of these other extreme life forms have. It can survive desiccation, it can be dried out. It can handle extreme heat, extreme cold, and high radiation. And so the researchers exposed this moss to Mars-like conditions and found that it was able to go into hibernation, and then it could be revived after better conditions were introduced. Now, it's important to say you can't just take this moss to Mars, plant it, and terraform the planet. That this moss would just nope out and just wait for better conditions to arrive. But if we were able to provide slightly better conditions on Mars, a bit of a thicker atmosphere, increase the temperatures a bit, maybe we could get some places where water might pool, then this is the kind of life that would help kickstart that process of terraforming a world like Mars. Every week, we do a vote on our channel where you tell us what you thought was the best space news of the week. And this week, the winner by a long shot was the results from the OSIRIS-REx mission. And that is fantastic. I'm so glad that everyone is excited about this as I was. I saw the rocket launch. I still remember that event. Now, we put the poll into our community tab within 24 hours of releasing this video, so go ahead and check for it there. Or if you're just scrolling in YouTube, you should see the poll show up. But the best chance is to subscribe to our channel, click on the notifications bell, watch a bunch of our videos, and that will train the algorithm to suggest our poll to you. Then give us a vote, and we will celebrate it next week. A planet that smells like rotten eggs. Earlier, we talked about James Webb being used to detect the atmosphere of an exoplanet, but this is just one of several stories that broke this week about this exact same process. Like, buckle up, this is going to keep happening. This time, the planet had the presence of hydrogen sulfide in its atmosphere, and this is the chemical that produces the smell of rotten eggs. And it doesn't take very much, although, you know, there's a lot of other stuff going on in the atmosphere. Let me get the name of the planet. It's got a terrible name. HD1, does that have a, yeah, HD189733b. Yeah. So just to be clear, this is not an Earth-like world. This planet orbits 13 times closer to its star than Mercury does. It rains glass in the atmosphere. The winds go at 8,000 kilometers per hour. It's above 900 Celsius, but it passes in front of its star on a regular basis, and so it's really easy to measure. And there were other chemicals that were found in the atmosphere of this world, but the one that everyone is making the big case is hydrogen sulfide, seen for the first time. A gravitationally lensed quasar. Speaking of James Webb, I want to show you a really cool picture. This is a gravitationally lensed quasar that was captured by James Webb. Now, of course, gravitational lens, this is where you've got a galaxy cluster or galaxy that is in the foreground, and then a galaxy is passing directly behind it from our perspective, and you're getting this brightening of the light that is coming to us. And in some cases, the light follows separate different paths around the lensing object in the front. And so you get multiple versions of the same thing. And in this case, we've got multiple versions of a quasar around a foreground object. Now, quasars, these are supermassive black holes. They are blasting out material at incredible brightness. But you've got this galaxy where the light has taken 6 billion years to reach us that is being magnified by this foreground galaxy. But the picture just looks amazing. Evidence for an intermediate mass black hole. Now, we have stellar mass black holes and we have supermassive black holes. And stellar mass black holes, they are formed when a star, many times the mass of the sun, detonates as a supernova, and you end up with a black hole that is, 10 times the mass of the sun. But while supermassive black holes can be tens of billions of times the mass of the sun. So how do you get from one to the other? Now, the thought is that you have these smaller black holes that are finding each other. They merge into a larger black hole, and they find them another one. They merge into an even larger black hole. And eventually you double and double and double until you get to these millions and billions of times the mass of the sun. But if that's the case, then there should be those intermediate steps. The black holes are going to have thousands of times the mass of the sun, hundreds of thousands of times the mass of the sun. But the evidence for these black holes has been really rare. They've found some possible evidence that these things exist. And now it looks like the Hubble Space Telescope has found some of the best evidence so far for an intermediate mass black hole. The research was done by looking at the Omega Centauri cluster. This is a globular cluster, the largest one that we can see from here on Earth. It's only about 17,000 light years away, which I know sounds really far, but this thing is huge. It's as big as the moon. And so if you know where you're looking, you can see it with the unaided eye. And if you look in a telescope, it's stunning. You can only see it from the southern hemisphere, and I've had one opportunity to look through a telescope at the Omega cluster, and it's amazing. It's surprisingly massive for a globular cluster. It's about 10 times as many stars as your average standard one. It's kind of like a mini dwarf galaxy in a ball. And it's unusual because it actually rotates a lot faster than other globular clusters. It has about 10 million stars. So astronomers took 500 images of the Omega cluster that had been gathered over many years. They identified the motions of 1.4 million stars in the cluster, looking for anything that is moving too quickly. And so, think about the observations of the supermassive black hole at the heart of the Milky Way. You see these stars that are going around this empty spot in the sky, kind of like comets, going really, really fast, and yet they're somehow being held in orbits around nothing. And actually that nothing is a black hole with 4.1 million times the mass of the sun. So it's the same thing. You've got stars that are moving inside the Omega cluster too fast. They should be on escape velocity, but they're orbiting around something, and that something isn't visible. Based on the motions of these stars, astronomers calculated that there has to be an intermediate mass black hole with about 8,200 times the mass of the sun that is holding them with their gravity. And so more evidence that these mid-sized black holes actually exist. China chooses a new target for its asteroid intercept mission. On July 9th, the asteroid 2015 XF261 came within 50 million kilometers of Earth. And that is not very close. That's like a third the distance from the Earth to the sun. But yet this asteroid was very interesting because the Chinese Space Agency announced that they have chosen this as the target for their upcoming asteroid intercept mission. This is going to be very much like the DART mission, which NASA sent as a double asteroid redirection test. They smashed into an asteroid to see if they could change its orbit. But it's also kind of like the Hera mission, which the European Space Agency is launching shortly. And this is a mission that's going to go to asteroid Dimorphos, the one that DART crashed into, and study it, trying to understand what happened as the after effect. The Chinese mission is going to both slam into an asteroid and have a separate spacecraft that's going to be able to observe the repercussions of the impact. Now, originally, China had planned a different asteroid target and they were going to launch in 2025. They've changed the target to this new one, XF261, and now they're launching in 2027. And we don't really know why they changed the date and the target. Maybe the development of the spacecraft is taking longer, but we should see a second test coming in the next couple of years. Ariane 6 lifts off. We've been waiting several years for Europe's successor to the Ariane 5 rocket. This incredible rocket launched over 100 satellites, including James Webb, but after their final launch about a year ago, they haven't had any more of these heavy lift vehicles. And that's because all eyes were on the successor to Ariane 5, the Ariane 6. And finally, on July 9th, we got the first launch of the Ariane 6 rocket. And everything looked great. The rocket took off, it separated, it released its 9 satellites into low Earth orbit, performed a bunch of science experiments, and then it was supposed to do a refiring of its upper stage rocket so that it could then deorbit the upper stage, as well as perform some more experiments as it was coming back down through the Earth's atmosphere. Unfortunately, the refiring didn't work, and so instead of that booster coming back down, reducing the amount of space junk, it is now left in orbit. But every other part of the rocket worked exactly as planned. Now, why have they got the Ariane 6? Well, they wanted to have a more modular rocket. So now they've got different configurations. They can launch different payloads. This one was done with the 2 booster configuration. They've got a 4 booster configuration that should be able to launch 20 tons into low Earth orbit. Now, with the mostly successful launch of Ariane 6 out of the way, they've got commercial customers that are coming up. And so now Europe has a heavy lift vehicle again. Now, I want to talk some more about the Ariane 6 and sort of the lack of reusability in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Bill, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Modzo, Paul Rohrbach, Stephen Krasaki, Stephen Fowler Munley, Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. The launch of the Ariane 6 has been a long time coming. You know, we first learned about this rocket back in 2014, and when that happened, these sort of next generation revolution in reusable spacecraft hadn't quite happened yet. We knew about the Falcon 9 and the path towards reusability, but we weren't at the level of, you know, rockets being used over a dozen times, the decreasing costs associated with all of these successful reused rockets. Back in the day, Europe was looking for an incremental improvement on the Ariane 5 and not to go down this full path of full reusability. They were looking for a rocket that could deliver heavy payloads into low Earth orbit, but also because the launch complex is located near the equator, it's one of the best sites to be able to launch payloads into geosynchronous orbit. But things have changed. It's been a revolution in the rocket launch market. We have everything that's happening with SpaceX with Falcon 9. We've got Electron. And then, of course, you've got the work that's being done for Starship. And so, you know, that launch payload that I mentioned earlier on, 20 tons to low Earth orbit, that sounds like a lot. But compare that. When New Glenn, with some level of reusability, comes online, it should be able to launch 45 tons to low Earth orbit. SLS, not reusable, should be able to launch 95 tons to low Earth orbit. And Starship, in its full reusability mode, theoretically should be able to launch 100 tons into low Earth orbit and then be fully reusable. And so back in the day, Arianespace said, this is the plan. We're moving with another fully disposable rocket that's going to be better than the Ariane 5 with a bunch of incremental improvements. And then they watched as SpaceX took over the entire market and yet continued on the way with this. And so now they have the Ariane 6 flying. It's time to think of a response, some kind of reusable rocket that can fly, be able to bring down the costs, make Europe a serious competitor to what SpaceX is doing. Because right now, a lot of the launches that would have happened from European rockets is now being launched on SpaceX rockets. And when Starship gets flying, then it could take the bottom out of the entire market. And so I think just across the entire space agency, you've just got to take the potential for rocket reusability into account as you design your new launch platforms. And hopefully Ariane 7 will be reusable. All right, we'll see you next week.